So this is our standard we're looking at. We want to understand relations and functions, and there's some key features in each of these functions we want to identify. Help us to understand really what a function is in relationship to a relation. Now, in our definitions, we've already defined domain and range. We've already defined them as to being an input and an output in X and Y. Really, we've given you three ways to describe the same thing. For a domain, we call a domain an X value. We can call it an input, and we call it a domain. Or with a range, we call a range a Y value, a range, or an output. All of those are the same things. And so really, we're just talking about something pretty fundamental here. And we've given you three different ways to describe something. Let's look at an example. Now, this is a relation that represents the number of whole wheat cracker boxes sold and the money earned. For example, if you sell one box, you'll make $4. If you sell 2 boxes, you make $8. If you sell 3 boxes, you make 12. 4 boxes, you make 16. And you're going to write a table in your notes, and you can do it with just a simple T-chart like that. And you can just say X and Y, input, output. All right, so you don't have to make it complicated or pretty or fancy like the table I have. But my inputs values are 1, my output's 4, 2 and 8, 3 and 12, and 4 and 16. But I might want to identify just the domain. So the domain is 1, 2, 3, and 4. And my range, my Y values then are 4, 8, 12, and 16. So they're related. Now, one thing about domain and range, I don't know that I'll always be able to tell if I just state a domain and state the range, what are the actual pairs? You know, I can only tell that if it's written, say, in this notation here, or if it's found in a table, or a graph, or a mapping. But just writing domain and range, those might not correspond. And we take that same information and we can represent it on a graph. I just gave you some graph paper. You'd have to kind of establish that maybe this first notch means 4, and 8, 12, 16, and 20, just like that. If I go to graph those things, if I sell 1 box, I make $4. 2 boxes, I make 8. 3 boxes, 12, and 4, 16. So that's what it would look like on the graph. And then if I wanted to map that, well, I just simply write them in order from smallest to largest, 1, 2, 3, 4. So that's my domain. My range is 4, 8, 12, and 16. And to map it, then I just match them up with a line. And this happens to work very neatly so that it maps straight across. So that's what a mapping would look like with this relation. It's going to tell us some things as we map them out. Actually, looking at mapping and looking at graphs, looking at the table, we're also going to be able to find when it's a function and when it's not a function. Remember, a function is a very specific, special kind of situation where it has a unique output. Let's look at another example. For this relation, we're comparing boys' ages to their height. Okay, so if I look at my information, my relation here, if a young man's 7 years old, I've measured him, he turns out to be 41 inches high. This one's 8 years old, 45, 9 years old, 49. I have a 10-year-old that's 52 inches and a 10-year-old that's 53 inches. Is that possible? Can that happen? Yeah. Same age, be different heights? Sure. 11 years old, 55. 12 years old, 59. So if I put that same relation in a table, the table would look like this: 7 and 41, 8 and 45, 9 and 49, 10 and 52, 10 and 53, 11 and 55, and 12 and 59. What's my domain? If I wrote the domain out in brackets like this, what would be my domain for this relation? 7, what's the next one? Speak up. What? 8, what's the next one?
9.
Yeah, what's the next one?
10.
What's the next one?
11.
Well, yeah, we don't have to write 10 twice, you're right. So let's write 11. And what's the next one? 12, very good. So, if I'm writing out the domain, it doesn't make sense to write 10 twice. We're not going to do that. What about the range?
41.
Okay. Keep going. What else?
Mr. Roberts?
Yes, ma'am. Yes, ma'am. 49. 52. 53, 55, and 59. And our internet has died.
I can't do anything on the computer.
That's all right. Just look up here. Did the lights blink too?
Yeah.
You know what I think's going on? I think there's a construction worker out there going, what if this is important? Plugging something in. Unplugs it, plugs it back in, unplugs it. Huh? Well, we'll keep going till it comes up. Of course, now my video's all messed up. It was my last shot. Every time I tried to do a video today, it's crashed on me. So anyway, I've got the definition, so that's at least something. If I'm going to graph this, it's 7 and 41, okay? So it's going to graph it right about there. 8 and 45, 9 and 49, 10 and 52, and 10 and 53, just like that. 11 and 55, and 12 and 59. Okay? And if I do the mappings are going to be very similar. 7 maps of 41, 8 maps of 45, 9 maps of 49, 10 maps with 52 and 53, 11 maps to 55, 12, 59. So what do you think? A minute ago we defined a function as a unique mapping there, right? So looking at it, what would you say? Is this a function?
No,
Why not?
because the reason this cannot be a function is because because there is not an x input for every y input.
Okay. Think we're onto it here.